So this is just more of a demo / tutorial on RTL SDR radios. If you don't know that, they're very. This thing here is $20 US, or maybe less now, from every website on the internet. They're really cheap. They're actually intended to be TV receivers, but for your computer. So you can buy these and actually have a debug mode that lets you look at all the radio spectrum up to about 1.something gigahertz. So you've got quite a range. I don't know the exact range because I never bothered to check. But it's fun for wireless things like this, which is a $25 doorbell from Bunnings. It's just a doorbell like you would expect any other doorbell. Anyway, so to give you an idea of what the signal is, we have this over here gives you a nice spectrum view of the radio spectrum when it starts. There we go. So if we're currently looking at 433 megahertz, not that button, that button. There we go. And if I press the button, you can see it peaking there on the side. I love that frame rate. Yeah. Anyway, so it's there. You're looking at the signal that's gone past. Like, cool. I can see a signal. What do I do with that? Like, how do I integrate that into my whatever? Well, let's just zoom out again because I can't see what I'm doing. We have this thing called RTL 433. Which is
the frame rate is dependent on being zoomed on zoomed.
Apparently. Yeah. Anyway, what I wanted to show was this lovely tool here. It's an open source C library, whatever. It's an executable program called RTL 433. That interfaces with a lot of things over the 433 and 866 and 915 megahertz, all the ISM bands in the sub-gigahertz range. And they support a lot of devices, so weather stations, temperature sensors, if they exist. There's a nice list of them here. So we've got a switch transmitter, temperature transmitter, energy count, don't know what that is. Yeah, so if you run the program with no parameters with an SDR plugged in, you'll actually receive everything around you that's transmitting. So I have it, I'll actually just reconnect the dongle over here, connect. So we go RTL, so -433. No, maybe it's underscore 433. There we go. So we run that. It's enabled all the protocols by default. It probably won't detect anything because we're in the middle of office space with lots of metal things that block signals. But you notice that if I press the doorbell, there's nothing coming up at all on the side there. I mean, this is 433 megahertz. This is a 433 program, but there's nothing going on. So it gives you this nice feature called analysis mode, which we can, if we go help, and we make this window bigger because screw that. There we go. So we have the analysis mode, which is here, which is print a textual description of the signal and disables decoding. If we pair that with another option, which is -T, is a test signal autosave. So when you're analyzing a signal, I'll actually capture the raw signal, the RF waves it receives, to a file for future analysis. So if we run... That's right, it's not a video. So if we enable that mode, another gotcha, oops. There we go. So if we go analysis mode and save signal mode, but we have to, and a gotcha, why is it TV? Okay. You notice that it's actually enabled the receivers of registering protocol 87 generic wireless motion sensor. We don't want those. Unfortunately, you have to disable them by hand, which you just go register 0, which means don't register anything. Sorry, that's really tiny. Not that button. This button. There we go. Anyway, it's picked up something, doesn't know what it is, but it wasn't what I wrote. It wasn't this big. So if I press it again, you'll notice that, oh look, there's a signal. If I press it again and again, you know, so it keeps it's actually picking up the doorbell, but it doesn't know how to really decode it. And so what it's doing is it's saving it to a file which is G004 underscore the frequency underscore the sample rate. So we go, okay, cool. Unfortunately, I saved this into the root folder, so there they are, G001, G002. Oh man, my mouse is tiny.
I like the .sudo as admin file.
Yeah, it's a feature of Ubuntu to test if sudo works for the root account. Anyway, so with that, what we've just done is that with RTF43, we've just captured some sample files of me pressing remote. Cool. How do we analyze that? Well, funny enough, the tool has a analysis mode as well. So if we look at this and scroll up, there'll be a capital A pulse analyzer, pulse analysis, and a decoded attempt. So I'll actually try to figure out what that signal was and try and decode it for you to get a binary representation of it. So if we go RTL underscore 433 -A. However, capital A is trying to decode from a live signal, but we've just pressed the thing, we've already got the file saved for future analysis, so say if we caught off a rare chance, we want to know what is later date, we want to read out a file. So there is actually another option down here, which is read data from input file instead of the receiver, which is quite handy. So we go -R, G00, -2, I press that, and then we press enter. Oh look, this looks like gibberish. So what we see here is it goes, oh, we detected an OK package, which is actually not the one. I should scroll up a bit. If I could scroll up a bit. There we go. Oh no, that was it. Cool. So it's mostly meaningless, but I actually don't know what OK stands for. But it does some basic telemetry, so it tries to measure the width of the radio signal pulses after demodulated from 433. It tries to measure the gap between them, and then it tries to measure the grouping of those signals. And then based on statistics that other people have gathered in the past, that they try and build some algorithms to try and detect what you're looking at, it goes, oh, it's guessing that it's a Manchester encoding, which is cool. So it tries to decode it using these values, which is 104, which up here. This bothers me. See, it says 416 microseconds width, but 104 is some arbitrary number. It's a times 4. I don't know why they've done that, but the number you're actually really interested in is the microsecond width, not the arbitrary number width. So it's doing a decoding of the short limit of the Manchester encoding is 416 microseconds with a 0, so a long limit of 0 because it doesn't care about long limit, and then it'll reset the signal after 210, which is about 800 microseconds. Okay, cool. And after that, we can see down here, this is actually that's the actual value it decoded from the doorbell, which is 17 bits long of 2481.8. The 0 there is sort of just padding because it's not quite 24 bits, it's only 17. Okay, cool. What use is that to us? Well, RTL43 now has another feature, which is you can provide your own specification of how to decode things. So you've just done some analysis and it's given you some numbers to work with. And it has a spec mode, which is -X. And you ask for help on that, it goes, well, if you can specify a modulation type, you can specify the timings of it, and it will try and decode that data for you. And I've done this beforehand, but looking at the values that we got previously, hold on a second. Back to Windows here and scroll down. Ooh. So that's our timing data that we got of 110 or 104, that's pretty close. And that's the pulp output. It also actually gives you an example of how to format that spec. So, yeah, it says if you want to register a new spec, we'll pad it with the name Doorbell. It's using and this is an example string of using the pulse width modulation raw of 400 microseconds with 800 milliseconds max width. So 400 is like a 0 and 800 is a 1, and then a gap. So the grouping of them, as long as the grouping doesn't space out more than 7,000 microseconds, then they'll consider it the same message. This is just some additional filtering if you want to try and group repeating messages together, but we won't use that in this case. So if we go RTL or 3x, if we go say Doorbell, and we go, what was it? So it was Manchester encoding, so let's just scroll up here a bit. Manchester coding with a fixed 0 leading 0 bit, which is actually what the thing for it was up here. So that's the modulation I try to use, so we'll just use that. Oops, use so quick. No. I didn't hit the right button. There we go.
It looks like a password.
It does look like well, no, it's not a password. My password manager clears up the clipboard, so don't worry. So it was a short of 104, sorry, not 100, it was 400 something, right? I really love this interface. So 440 microseconds was close enough. Don't care about the 0, and then so the spacing between each message, it was estimating about 1,200 microsecond spacing, which was that weird 400 number we saw earlier. So we go 1200, and I think that's all we need. And of course, let's just disable the other decoders because that's just annoying. Oops.
You've got a unquoted.
Oh, that's awkward. That looks better. So there's a button. Hey, look, we have a doorbell. Almost. No, that's correct. Yep. So 17 bits with our 24818. Yay! Finally, I built a script around this.
So, dumb question, Roman.
Yes.
From what you showed me there, it looks like you're taking a lot of the output from the analytics tool and pasting it into the parser tool.
Yeah, it's a manual step process because you need to do some guesstimates.
Yeah.
Trying to figure out, does this work? Like I spent a good day on this alone. To boil it down in 5 minutes is kind of like, okay, I've now understood the process. It's a matter of understanding the different types of encoding modulation methods that radio transmissions use. Like this one is Manchester, the one I have at home is pulse width modulation, the one we have at work is, I've forgotten already, something
You managed
else.
to figure out how to do the bucket
Sorry?
decoding?
Yeah.
Like my fan at home, I've got good dumps from an RTL SDR, I've got good dumps from a 433 $2 chip, and I've got good dumps from an RF bridge that even has its own microcontroller. So I've got good dumps for it, but it does a key shift based on some sort of timing thing with the remote.
Oh yeah.
And then it does repeats into buckets. So oh god, it's a pain in the ass. I've been talking to like 2 or 3 people about it for about 2 or 3 months. No one can figure out how I can get something that I can transmit with it.
So Roman can be high.
Yeah, exactly.
Rates.
I'll give you the data. You can try and figure it out. It's like maybe we should take the KiwiCon.
It was
It's like figure out my fan for me at KiwiCon.
in the CFP.
Yeah, exactly.
It's part of the badge show.
Yeah, exactly.
There's a video on YouTube, I can't remember, it might have been channeled like Veritas or something, but in relation to garage door opening and like using a similar approach, and they ran into one which had a change in code, but they managed to get it to, like, if you could stop, I think it was something like if you could stop the receiver from receiving a particular code or vice versa. It was something where if you ended up having 2 codes, then then it meant that you could like reuse
I
it.
have thought about that, or someone suggested that to me. It's like, it looks like every time, the first time you use the remote after like an hour, it looks like it's sending this extra set of commands saying resync the remote, and then it sends the command again after it's synced.
Right.
So if there's some way to make your sender, in this case a 433 bridge, see that command, figure out what that is, and you might be able to get a chance to actually see. Because I know what I need to send it.
Yeah.
Like, it's just that there's this checksum at the start that seems to roll, and no one can figure out before the life of us how that rolls.
So, what I'm doing here while you guys are talking is I actually have a script that takes in the spec, as you saw me type out here, and sends it to a webhook with an assortment of jokes. So, no, that's not the one I
Good old
wanted.
copy buffers.
Yeah, well, it's VMware not being particularly interested in helping.
Oh, and according to the internet, ook is on off key. So it's literally carrier signal, no carrier signal.
There we go. So that's a webhook, and then we
Use some preface and vice versa.
you see nothing. And just fix that with our doorbell, which is. Where did I put it? Sorry. That's why I save it down here for future use. Because who loves copy paste? Sorry, this is the boring part I was hoping to talk about, but it's not really that interesting. Unless if you're interested, I can give you the GitHub repo for this. It's a 17 bits wide, and it was, oh god, Tommel doesn't like hex values. What was it? So it was 2481 something, so hex 24 is 36. 36, and then 129, and then 128. Cool. That, save and go doorbell. Oh, actually, sorry, I've got one step, and this is because virtual environments save the day. So this Python script actually runs RTL403 with those specs that I gave it behind the scenes, and will listen out for, I'll actually read the STD outputs, so one of the program outputs, and it goes, oh hey, I received a doorbell signal, and it goes, well, it failed to grab the cat fact from the internet, sadly, but because I posted it to a webhook, if we go over to the webhook, maybe it's going to work. It should have posted a webhook to the scene to go, hey, here is some random cat fact, because I like cat facts. Oh look, sloth facts too. Sloths are actually cat facts too. Yeah, so that's sort of the RTL, there we go, so it's posted to a webhook. So the reason for this is because Mattermost has a webhook thing, so you can write messages to your chat, and I do this to annoy everyone at work. Every time the doorbell gets pressed, cat facts show up and our main chat room. And sloth facts at a request of our boss. So yeah, that is the talk, and hopefully to demonstrate that RTL43 is quite useful in analysing radio signals and decoding them in such a way that you now have a binary format to work with. If you have any questions, I'm happy to answer them.
Cool, man.
Yes.
Oh, can you press it again, please?
Oh.
I didn't see the first time.
Oh, more sloth facts.
Oh, sweet.
So there it is again, and the message says, sloth fact, all sloths actually have 3 toes. Oh, so that's the one from before. Maybe they're in backwards order. Where is that? There we go.
Or maybe it's actually sloth fact, singular.
Yeah, but as you can see, every time I press a doorbell, a new fact pops up. Oh, there's a cat fact this time. Lions are the only cats that live in groups. Called prides. Every female with no pride is usually related. Awkward. Yeah. So that is my wonderful doorbell bot thing that posts webhooks. The URL, which I hopefully you still have open somewhere, not that one. on that one.
That's actually super useful to learn about that because I've got it was a thing from Bunnings for remote control power.
So it's from Bunnings too.
Yeah, but the cool thing about it is it's as sold, it controls 3 different outputs.
Yeah.
And
The one at our work has a tone tone button, where the doorbell itself tells the doorbell unit what tone to play. So you know 3 different doorbells with different tones each, which changes a bit around, which is annoying. So if someone changes the tone, well, you have to add in that.
If you're really lucky, then you live on a hill, you can get weather reports from dozens of people. For free. You don't need to put your own weather station.
So that was supposed to be the other part of the talk. So at home, we have a webcam facing out to the driveway, and we live on top of a hill, so we see everything, and we actually have line sight to the airport. It's lovely. We're supposed to post webcam photos. It's the doorbell at home. You can see people walking up the driveway, so when the doorbell gets pressed, it shows the last 5 pictures that are snapshotted of the driveway into our main chat. But I didn't get that working for tonight, I'm sorry. Yeah.
So the 433 megahertz band, I'm assuming is an unregulated one for New Zealand?
No, it's ISM. So 433 and 915 are the 2 ISM bands for New Zealand. 868 is not allowed.
Yes.
It is.
ISM being
Instrument, scientific,
industrial scientific.
industrial, scientific, and medical.
Okay.
Yeah, it's a free for all. Like 2.4 gigahertz is ISM.
Okay. Yep.
Yeah, that just means unlicensed up to a certain wattage.
Sure.
And you could also potentially take the information from this and go the other way if you had a 433 module hooked up to Arduino to send the signal.
Yeah, if you want to really piss off your neighbours, yes. In fact, there's a device called a yardstick, which will do just that. It's kind of pricey, but it's a very fun hacker developer tool.
Someone will make one for $10. You can get one of a nice little USB microphone factor with Wi-Fi control.
Yeah.
And it has a separate microcontroller for the 433 radio that you can flash an extended firmware that'll let you do raw dumps. It's great.
What is it?
It's an ESP 8266 with
There's a theme here.
50 cents RF 4.3 receiver and transceiver in a nice little form factor with a bi-volt converter, so it takes micro USB.
Yeah.
And it also has an easy 88 microcontroller specifically for doing the RF component. And it's got a nice little dip switch you can flex. It's got the JTAG headers inside. And they're literally like $9.
What's it called?
A Sonoff RF bridge.
Oh, Sonoff. Yeah.
Yep. And they're great, and then the Tesmo firmware has support for the hacked firmware on the RF bridge to do full dumping as well.
Broadlink had an RF.
Yeah, I bought a Broadlink. It was one of my first IoT devices, and it was the RF plus the IR. And it's little, but it's so limited anyway. It's the Wi-Fi chips that they're using is really limited. You can't hack it. And I ended up scrounging the IR LEDs from and just putting them on the project. So it was useful.
What's that SDR you mentioned, Roman?
So this one we bought from AliExpress.
Yeah.
It's just the RTL SDRs, sort of the keyword we want to look for.
There's a couple of slight variations on the model. So the really cheap ones go up to about 1700 meg.
Yeah.
And then the slightly more expensive ones, a few more dollars, go to I think 2200, something like that.
Because some of them aren't supported by the flight tracking sites.
Right.
I think I bought one that looks very similar, it's got the same aerial, but I can't use it for flight tracking, so I ended up buying a proper one.
The one that I bought actually has a temperature stabilized oscillator, so it doesn't drift when as it warms up, which is kind of annoying.
For about double the price, for like $50, you can get a proper hack RF common from AliExpress. It's actually designed for this purpose, as opposed to a DVT dongle that people have figured out you can kind of screw with, which is what this is. So the hack RF has a nicer SMA antenna on it, so it's much more sensitive and probably is temperature.
Sorry, I'm just having fun with these messages. Yeah. Well, my talk's over, by the way. I don't know what yours is.
You don't have to go home, and I guess you can stay here for a while. So
I just want to watch more
have a
facts.
chat.
Again.
I'm still pressing in my hand. Just.
Yeah, just keep going.
That's a good stuff.
I have a relation,
This,
a relation.
Awesome, thank you everyone. Feel free to have a beer, have a chat. But yeah, that's the end of the talks for tonight. And I'll send out the meetup update with next month's talks, as well as the YouTube videos once we process those as well. Cheers.
Thank you.
Thank you, sir.
No worries.